Hey there, everybody. This is Greg Henderson, prospector and mechanic and a bit of an inventor. You may have seen me on Curse of the Frozen Gold on History Channel and Animal Planet. I'm the guy that was building some of the equipment for the guys, and I've decided that I wanted to build a impact rock crusher for some of the ore that we've collected over the years. And as you can see, this is my shop, and it's in my yard. Actually, this is my shop in my backyard. You can pretty much build anything here, and I wanted to build a rock crusher out of a 7-inch angle grinder, just because it has a bit of a portable factor to it, and I can take it into the field if we need be and process ore while we're there. We can put it on a backpack as well as just bring a gen set in. So I haven't really had the ability to process any kind of rock ore, and I wasn't really happy with the small processing impact mills that guys were building on YouTube. So I thought I'd try to build my own, and I'm going to show you guys the stages of how to build it, and any of the pitfalls or any of the problems that I have along the way, I'll let you guys know. All right, well, here goes the build. So here we begin the build of a rock crusher. It's my shop and my house here. My old Pontiac, my kids' go-karts. Yeah, the whole idea here eventually is to take some of these ore samples that I have. I've got some fantastic samples. We want to crush them because we've got hundreds of pounds of them, and we know that there's gold in them. So I'm going to build a small portable crusher, but bigger than stuff that's on the market. So I'm going to start with this 7-inch Makita grinder. I'm going to use the handle supports as well as the 4 screws here to build a, I guess you'd call it just basically a mechanical spin crusher or impact crushing tool. I just bought a 1-inch pillow block, sheared up some plate, and I got this from the local metal supplier for $15. And I got lots of good quality welded chain. Got some solid bar stock, 1-inch bar stock. And first step is I'll bring it over to the lathe, and I'll start machining the 1-inch bar stock. I mean, you could get away with doing this other ways, but I mean, I've got the tools here. I'm just going to take that 1-inch bar stock, drill a hole in it, put a 5/8 national coarse thread, which is what that is right there. And I'll screw it on, and I'll just put a hole through the shaft. I could machine it down so it had a hex head on it, but I'm not going to. I'm just going to put a hole through it so I can take it on and off this thing, so I can still use my 30-year-old Makita grinder, which works great. But I think this thing should work pretty good. So I'll get on with the build. So I'll just put the bar stock in the lathe here. Let's clean up the end here. We'll machine it off. Okay, we're just going to machine off this 1-inch bar stock. Just face it off. Okay, we faced it off now. I'm just going to drill it out. So drilled that out. Basically 1732 drill was what you need for a 5/8 national coarse thread. The beauty of having a phase converter on a lathe or a mill is you can do some tapping pretty easy. Nope. I'll tighten that up. And just hit the reverse. Forward, reverse, forward, reverse. And just keep tapping until it bottoms out. And then it gets stuck. There we go. Okay, well, we've machined it, and I've counterbored it slightly so that it'll fit over this little washer bump that's in here, so that when I tighten this thing up, it's going to tighten up against the flange. So that's the next step, is to start finding the center on the plate so I can put the pillow block in, drill a hole through there, and continue the build. So we'll just find the center, describe it, find center, and then we'll center punch that, start drilling our holes. Okay, now we'll drill it. If you're wondering how big this is just 9x9. Just happen to have some 9x9 quarter plate kicking around, so there was nothing pre-planned on this build. It was just build it with what I had kicking around here in the shop. So if you build your own, build it bigger, build it smaller, it doesn't really matter. Okay, now we'll just drill these 5 holes. Done. One step closer. By the looks of it, we did an okay job. Centered up all the holes. Looking good. Okay, now we can take our hole saw out and drill out that 1-inch hole there. I'm going to drill it out slightly larger than 1 inch because I want that shaft to fit through into the inner race of that bearing and not obviously contact the plate. But I don't want to make it too big either because I don't want to get crud caught up in behind the bearing. So this thing's going to be pretty close to 1 inch, maybe 1 inch 20 thou or something like that. Well, I just realized I have every hole saw size except for 1 inch, so I guess we'll have to go over to the mill and mill this out to 1 inch with the mill. Just going to clean up all the corners now and give these a little bit of a rounding so that this thing isn't so dangerous to touch, man. The thing's just like a razor blade. Okay, so I've machined down the 1-inch shaft to fit the pillow block perfect. Seems that these offshore bearings aren't quite 1 inch, or maybe the shaft wasn't, so I just machined it down a little bit. So we got a nice fit. Got to open that up a bit because that's going to be a rotating shaft in there, obviously. It's got to rotate in that hole, and there's not enough clearance there right now, but you can see that if I put too much clearance in there, some of the gold ore could get up in behind the bearing and we might lose actually gold right in behind here. So all the little things you got to consider I never even thought about. So I'll open that up a little bit more, drill those holes out, and then we can start welding things up. Alright, it's looking good. So we'll just enlarge these holes, and then we can actually bolt up our pillow block and see if it all fits right. Okay, so there we go. Got ourselves the pillow block bolted in. I'm a little bit worried about what's going to happen inside here when things are flying around, though. Thinking it's going to probably tear the hell out of these grade 8 bolts when you've got quartz flying around inside here along with the chains, but hey, we'll cross that path when we get to it. If we have to, we'll change the design slightly as we go. But hey, if I got to change out a few bolts and nuts from time to time, no big deal, right? Okay, we're about a quarter way through. Have to make up 4 little small spacers. Between the plate, right down in there, flip it over into the light. So that's where the spacers will go. They don't have to be special. I mean, a guy could do this at home with a bunch of washers. I just got a lathe, so I'll just make them up out of steel, give it a little bit of support in behind. And then I'm going to build an L bracket off of the main handle support that normally be here, because I think if you're only supporting off these 4 small 4mm bolts, you probably shear that plate off if you ever get a jam. And I think you need that big 3/8 bolt that's there to support both plates. Right? Okay, well, this thing's really coming along. Worked on it for about 2.5 hours now, I guess. Maybe 3 hours. Sort of putting along, and so there's my center shaft. There's my piece that'll go here. And then my top plate. Go together like that, and I'll shorten up that shaft, but you can see how this thing's coming together pretty good. Greening in it. So I've just cut off some angle iron for my 2 little support brackets. So you can see what I'm going to do here. I'm just going to do that, bolt through, and then we've got ourselves support on all 4 areas. We got the down here, those 4 areas there, and on the sides. And that should be strong enough. Whenever I'm working with angle iron, though, I always want to round the edges as much as I can. I always think it looks a little less industrial. So I'm going to just round that edge there like that, round that edge there like that, and I'll show you what it'll look like after. So now that support piece is going to sit like that in the tool. I think that gives it a nicer look, right? Rather than that kind of scabbed look like someone just sort of hacked it out of angle iron. And sometimes I even round over the edges right in here, just so that it gives it a nicer look too. I know this isn't a showpiece or anything, but I used to fabricate race car stuff, and you know, you always wanted things to look a little less industrial and more trick looking. So that's the kind of thing I incorporate into almost everything I build. So next part of the build coming up. Okay, so we fabbed up those 2 little angle iron brackets. They're kind of a little prettier than they did before. Rolled everything over, cleaned it off a bit. They're going to paint all this up. It's going to look kind of nice after. But it's got a mark and drill, bolt it up, and then I'll weld it in place when it's bolted. That way I know my alignment will be correct with the holes that are in here. I mean, the guy could weld it first and then drill the holes, but then you're kind of guessing where things should be. Alright. Okay, so now we have our angle brackets made up and bolted up in place. You can see that. Nice fitment. And I'm just going to tack these, and I'm going to tack these little spacers that I made up too, so that when I take this thing apart I don't lose them. I mean, I could just leave them the way they are, but I'm going to tack them in place now that all the bolt holes are lined up. So I'll get this thing set up for welding and we'll tack them in place. Okay, so that's tacked the angle iron pieces and the 2 front small dowel spacers. Now I can take it apart and turn it around here, and I can tack the other ones from underneath. And then we'll do a finish weld after we take it apart. Okay, so we'll just finish welding this thing up. Yeah, it's not too bad. A bit ugly. It'll do. It's not a show car. So I've taken my big piece of pipe and I laid out where I kind of want my cutout for my tubing. I just gotta grab the piece of scabbed up tubing. I got a bunch of this stuff lying around. So just marked it. Pretty grungy piece of steel, but it'll do. So you could just you could use a cut-off wheel here, hacksaw, power hacksaw, whatever. I'm lucky enough to have this nice little plasma cutter, so I'm going to use the plasma cutter on here, and it'll just make a nice clean cut. And then I can just finish it up with a grinder, and then I can mock up where I want my cutout, and I'll just tack weld it to the pipe. And then what I'll do is then just get a Sharpie and trace around, and then break the weld away, and then I'll have a nice traced out line where I need to cut into the pipe for my entrance for my ore pipe. And we can just clean that up with a grinder now. So we're almost there with our grinding. Just got to grind a little bit more off of here. So get in here and just grind away. So that side's looking good. Just got to do the opposite side. Okay, so I finished that other side now, and as you can see, looks like the fitment's almost perfect. Remember, I don't know, I mean, this isn't a very structural component, obviously, but anytime you're doing any welding between two pieces, fitment is key to getting a good, strong weld. And you know what? You want to make your stuff look pretty too, right? It has more value to it. People don't think you're a hack. I've always been one that sort of likes a bit of pride in what I do. Even though I'm just kind of throwing this together with hacked up pieces of steel, as you can see, I think the end result is probably going to end up looking pretty good. And hopefully it works as good as it looks. So I just shimmed up the piece of tubing and ran it into the pipe, and I think what we can do is just use that as a pretty close eyeball of where it should be, and I'll just run the Sharpie around this thing and just mark it off. I don't even need to tack it. So now we've got our marks back for our entranceway into our crusher, so I'll just plasma cut this out. Gloves on, eye protection, and I go to the inside of the trace. That guy could have used a straight edge and done this better, but I'm just going to knock out the hole, grind it up, weld it up, call it a day. So I've got some really nice thin wall tubing here that I'm going to use as my exit, and I'm going to take Jeff Williams' advice here and not put the exit at the bottom. He says it piles up and tends to get clogged. So I'm going to make my exit off to the side, kind of like this. And then I'll cut it and have it sort of facing down, and then I'm going to taper it off into a sort of a smaller exit point. So I'll make some pieces for this. I'm not going to go the traditional route and put plate in here like a slide-in piece. Okay, so we got that done. We got it roughed out. I mean, I'm not going to clean this up perfectly. I mean, God, you're going to have rocks flying around there, and it's going to beat the hell out of this anyway. But I know that some of you guys at this point are probably going to ask me, well, why did you make your entranceway so big? You know, you can't put rocks that big down there anyway, right? Because it's such a small crusher. Well, in my view, you guys can correct me if I'm wrong, or time will tell. If I put a small entranceway like this, I'm limited to 1.5 to 2 inch pieces of material that I can put down. Whereas if I put a larger piece of material in here, it can be long and skinny, and if it sort of kicks a bit in here, it's not going to get jammed in this. At least I can limit the size I put into this one, but I can't increase this one any bigger than that. The way I look at it, I'd rather have a larger inlet and realize the limitations of the machine just through trial and error. I am using a 7-inch angle grinder as a motor, so I think it's got some pretty good speed. It'll have a massive amount of inertia with a 10-inch hole here. So the larger the inertia works based on the outside diameter of whatever you're spinning. So if you have a wheel that's this small and you're spinning it, it doesn't have near the inertia as a wheel that's spinning this big, and the chains end up being the end of the wheel. It's just like a flywheel on a car, right? The larger the flywheel, the more inertia it has. I'm not a scientist, but I am an automotive technician, so I understand the theory behind how this stuff works. So I feel that once this thing's up and rolling, it's going to have enough inertia to smash up some pretty large rock. Okay, so I've tacked our entry tube. Just going to weld it now. Okay, weld it up. Looking pretty good, I think. Nice. A bit of grinding, and then I can put the other entry tube portion on. Okay, well, we're back at it again today, so just going to chamfer back the edges here, so that when I weld the other piece on, the weld penetrates well and doesn't create a topical weld. Go. Okay, we'll tack this. Finish weld this up. Okay, so drilled all my holes. I'm not sure if they're going to be the right size. They're 1/8. Might be too small, I'm not sure. You can always make a hole bigger. It's tough to make a hole smaller, so. I also made my exit chute. The exit chute is gonna look something like this. I'm gonna shorten it right up to somewhere right around where my thumb is. And then I'm gonna neck it down into a smaller tube so it can just go right into a bucket. So I'm just gonna shorten this up. And then I'm gonna have this exit tube removable, so that if my holes plug up, I can just poke a piece of steel through it, and when this wears out, all I have to do is just weld in here. Just run a couple beads with my MIG in here, and then just re-drill through the back side. I'll have pilots all ready to go. So, done deal. Okay, so I fabbed up a little top plate. Got these weld-on hinges, a couple of these kicking around the shop, so gonna weld these to the top plate. They're pretty simple. They just pin that you weld to one side and the other, and then I'll weld a little tab off here so that it can't come and fall off, but then I can bend the tab back if I ever need to get a jam out of this thing. Then I can take this entire top plate off. So I'll make it removable. But it's a little forward weighted so that it's got a little bit of overhanging weight on it. Should sit something like that. Then I can tip it up and just drop it. The weight of itself will drop. Fab up this little piece of steel here that'll just prevent the hinge from falling off when it's rattling around. So piece, should be able to just clamp this. There we go. That should work. Yeah, that's pretty slick. If I ever want to get that top hinge off, I can just bend the tab back a little bit and it'll move out of the way. Okay, just going to weld this on then. Okay, we welded it. Weld the little tab on. That's not going anywhere. And I can bend that tab back if I ever want to get this off. I don't know why I would want to, but nice. Coming together slowly. I can probably powder coat this thing when it's done, make it look nice, but I got a nice piece of gold ore here. This is about the size I'd like to be able to try to process. I might be hoping for too much, but this thing's 3 inches long, 2.5 inches wide, but looks like it'll fit right in. If I have to go to smaller pieces, well, then I do. Nice ore though.
Attention summer lovers. Here's a few quick summer facts. Fact: Canadians love summer. No ice because winter's super cold.
Okay, this thing's really coming along now. I've bolted it all together. Now I just got to put the little gussets up in here for the front plate. Put the shaft in it, and then put the chains in. It'll be done. We're just making up these stanchions so that we can bolt this together. That'll be the last one. We've already tacked in the other ones. Alright. So I'm going to go a different route with the strike plates because I know a lot of guys sandwich chain between two plates and then they basically weld it like this, one on one side, one on the other, and it looks like hell. And to be honest with you, that plate's going to wear out. If that plate wears out, it's going to build a whole new shaft, and I don't want to have to do that. I want to do it a little bit different. I'm going to do it like this. And then bolt this direction, because then I can just take the shaft off, put it in my lathe, and then I can just turn this part right off and then just put another one on. I made up about 10 of these plates already, so when these strike plates wear out with the chain off of it, I'm just going to weld around in here, and then I'll just turn the shaft, put the shaft in centers on the lathe, and then just turn this plate off of it, and it'll be easier to repair that way rather than replace the whole shaft every time when the strike plate wears out. Okay, so this should be the action of these hammers when they're in the crusher and running. So here goes first fire up of this thing. It came together pretty well, I think, man. I'm pretty happy. So here's some of the ore that we want to try to process. I got some big pieces, small pieces. Obviously, I'm going to start with some small pieces first, see how it works. So here goes. Well, something I've realized right away is this is something that you shouldn't be doing inside the shop. Holy crap, this thing's pretty dusty. Probably should have a bucket hooked up to this thing and a vacuum cleaner. But I just threw in some 2-inch pieces and it just absolutely demolished them. I'm a little leery about throwing this big piece in, but I'm going to give it a go. Holy crap, this thing just rips. I don't even know if this will fit down the shaft. Well, we'll give it a try here. If it can smash this up, we've built ourselves an amazing ore crusher. Because this is just using an angle grinder. Here we go. No, got jammed. So it does have its limitations, but you know what? I could tell that it was trying to smash it. Wow, this thing's absolutely crushing this stuff. Amazing. So let's put another big chunk in it. Okay, I can't say how well this thing works. Holy crap, man. That was a 3-inch piece of ore that I just put in this thing. I don't know of any small crusher that is crushing pieces as big as this and processing it into absolute oblivion like this thing. So I'm absolutely stoked. We'll have to do some after pictures here and see what kind of gold's in this. All right. Time to paint her up. So this is the result. Literally powder. We'll have to pan this stuff out and see how much ore's in here, or actually how much gold's in here. Pretty happy though. Holy man, is this thing just rip it. I didn't even put the strike plates in this thing yet. I was pretty excited to just give it a try, and there's no strike plates in it at all. So we crushed down that ore. I know that this is gold bearing ore, so we're just going to pan some of it out. Tough to do one-handed here. Holy mackerel. There we go. Final take, a couple pieces of silver, and a few little pieces of gold in there too. Not much, but it's something. There's one of the little pieces of ore that didn't get crushed. Nice little piece of gold on it.